Are you finding it difficult to answer questions in set because you don't know the basics? Check out my link in the description below. You see the first types of sets we treated. For today's class, we'll be looking at subsets, proper subsets, equal sets, equivalent sets. Now, for supersets, when is a set said to be what? A superset. Given that A is equals to 1, 2, and a set B is equals to what? 1, 2, 3, 4. Now, superset is noted as this. B is said to be a superset of A if there exists at least one element in B that is not in A. Initially, A must be a what? A subset of what? Of B. For B to be a what? Superset of what? Of A. Now, as you can see, A has what? 1, 2, B has 1, 2, 3, 4. It means B contains A, and in which case, B has another element that is not in A. So in which case, what? B is a superset of what? Of A. If there is at least one element that is in B, not in A. Now that's superset. Now for proper set, proper subset, this is noted as what? As this. Now, from our example above, A is said to be a what? Proper subset of what? B. If all the elements in A can be found in B, it is related to subset also. So that's for proper subset. So that's for that. Now for equal set. For equal set, a set A is said to be equal to B. The notation is this. A is said to be equal to B if all the elements in A are the same thing as what? The elements in what? In B. Now in this case, we don't look at the numbers of elements in A and numbers of elements in B. So such that what? For C, if I was given 1, 2, 3, 4, and for D, I have 1, 2, 2, 3, 3, 3, 4, 4, 4. Since I can find 1, 1, I mean no element is distinct from D, it means that what? C is also equals to what? D in this case. Now for equivalent set, this is the notation. Okay. Now in which case, what happens? It implies that what? A set A is said to be equivalent to B if the number of elements in A is the same thing as what? Number of elements in what? In B. Such that what? For set A I have what? 1, 2, 3, 4, and for set B I have what? Something like A, B, C, D. I'm not looking at the same elements in the two of them, but such that what? Number of elements in A is the same as number of elements in what? In B. So number of A is equals to number of B is equals to what? Is equals to 4, and that is equivalent set. Now, that now moves on to what? Cardinality of a set. Now noted as what? N. Such that what? Given that A, set A is equals to what? A, B, C. Cardinality of A becomes what? N of A, which stands for what? Number of A. That's cardinality. And that's what? That's 3. Now, from there we'll now move to what? Finite set. Now, a set is said to be finite if the elements within that set is what? Is defined. If the element between that set is what? Is defined. Such that what? For set A, I have what? Numbering from what? 1 to what? To 10. That's a finite set. Another example is what? Something like this. B, such that what? I have 3, 20. Okay. C, set of prime numbers. Between 0 and what? 30. Okay, these are finite sets. Set of prime numbers between what? 0 and what? 30. So we have a defined number of what? Elements within that set. That's finite set. For infinite set, or infinite set. Infinite set is also called uncountable set. That's the set that the elements is not countable. Uncountable. Okay, just as finite set is called countable in that case then. Okay, so now set as A that will have 1, 2, 3, 4, and so on. Okay, we don't know the ending, but we know the beginning. Or set such as this, we don't know the ending. We don't know the beginning, I mean, but we know where to end, 1 to 10 in that case. This is also an example of what infinite set. Or set such as this, you don't know the beginning, we don't know the ending. Those are examples of what infinite set. Now that's about infinite set. Now for singleton set or unit set, okay, it is a set that what has only one element. Just as null set has no element or empty set has no element, singleton set has what? One element. This is an example. Or we have this as what? As this. One element present is what? Singleton set.